Hi guys, welcome to today's lesson. So today we are doing financial maths, specifically the future value annuities. So we're going to start by outlining exactly what is involved in financial maths, and then I will be explaining each concept as I am displaying it so that we can understand the bigger picture of everything that we are going to do, and then we'll start with the actual thing that we need to do now, which is the future value annuities. So let's just look at our outlines for now. So remember, we're talking about finance, and with finance, specifically in this particular level, we're going to look at future value. This is money that you get in the future, as it says, future value. So you put money now on a month-to-month basis, not a lump sum value, because that one is a compound interest concept. This also has what we call the sinking funds. So sinking funds, just to explain an overview of what a sinking fund is. Let's say you have a company, and you guys decide you buy photocopy machines, right? And you need those photocopy machines. They cost maybe 350,000. After 5 years, you will need to replace the photocopy machines. Why? Because there's a newer model, or the ones might be broken, or because the demands of the company have changed. When you then change those photocopy machines, the price would have gone up because of inflation. But the price of the photocopy machine that you bought now to replace later on would have depreciated because of the fact that it's loss in value. You've used it. A new thing and a used thing are different in terms of pricing. The difference between the depreciated value and the new value because of inflation is therefore what we call the sinking fund. So in simple terms, what you need to top up the money that you're going to get when you sell the ones that you have will be the sinking fund that you're talking about. So I hope that just gives you an idea of what a sinking fund is. Also, we have what we call annuities. Annuities also have to do with a month-to-month basis. And then we also have what we call a present value. As it says, this is a present value. It's the money you get now. But most of the time, this is not money that you own. It's money that you get from a bank, maybe because of a bond or because of a loan. So these are bond repayments and they are loans, as I said. But now we are focusing on future value. Now, have you ever thought about how can financial maths help you to save for the future, right? We know people saying, I am saving. If they give you money to go for lunch at school, you are saving maybe 30% of that. How can you do that in terms of your real life situation? And then how do some people grow money as well? Some people saying, I started with 10,000, now my 10,000 is 35,000. How did that happen, right? Those concepts, mostly we are going to base this on financial institutions that are allowing you to grow your money, right? Then also, what is the best way of saving money? Can we play a stokvel? That's one example. Or can I just go to an actual financial institution, which is what we're going to try and understand how do they actually work. The key words for future values will be the concept itself, future value. This is the money that you get in the future. So we can call it the accumulated amount, right? It's the amount that whatever you have now accumulates to in future. And then the value of installments, because we are talking about an annuity, this is on a month-to-month basis. So every month you put away maybe 300 rands, and then they give you a certain interest rate. Remember, interest has to do with the effective and the nominal interest rate, depending on what option you are opting for with the financial institution. We also have what you call the number of payments. Now, with the number of payments, the reason I call it number of payments and not number of years is because we're not gonna, in 6 years, I am not going to be paying on a yearly basis, so I won't have 6 payments. No. The first year I'm gonna have 12, the second year 12, that's 24, 36, like that, until I get to the 6 years that I will be contributing for that investment that I would be having at that time. Hence, we say it's number of payments, not number of years. Then we have annuities, which we spoke about, and then we have what we call the compound interest. And this, a future value is normally on a compound interest basis, not a simple interest. Now, an annuity is a number of equal payments made at regular intervals of time, right? And this interest is charged on these amounts. So what we're actually talking about, let's say I use maybe a number line of some sort, and I start at T0. At T0 is when I start the investment that I am trying to start, because now we're talking about investment, future value. And T1 will be after the first year. After the first year, you would have actually made 12 payments, right? At regular intervals. Regular intervals will be on a month-to-month basis. And then some people, because they're not so disciplined, this is where I answer the question, how do some people save for the future? Financial institutions, they bind you by a contract that you need to make this payment per month. If not, it's going to affect your credit report, your credit score, and if you want to take maybe a loan later on in the future, you won't be able to do that because you took a decision upon yourself that you want to make these payments, but you couldn't adhere to the rules of that particular decision you took. So that's what financial institutions do as well, to try and bind you to be disciplined. And then also with a future value annuity, capital is normally accumulated by means of regular equal payments into a savings account, which we just said, or an investment account. And this compound interest is normally paid on the money deposited into the fund. So we don't just calculate interest for the rest of your investment. As you are depositing, that's how they calculate the interest. This is the formula we use to talk about the future value annuity, which we're going to use at a later stage when we start calculating. It's F. Some people prefer FV. It's really up to you. It means one and the same thing. Is equals to X, open a bracket, another bracket, 1 plus I, all to the exponent of n minus 1 divided by I, where the F is the future value amount, X will be the amount that is paid in at regular intervals, the N will be the number of payments, and the I will be the interest. Now you will see we're going to be talking about compounded monthly, compounded quarterly. That talks to how often you get the interest on a yearly basis, right? If they say compounded quarterly, it means every quarter of the year you get interest. Monthly, every month you get interest. But for now, because we've been talking about a lot of concepts, I want us to take a quick ad break. When we come back, we're then going to apply this formula to see exactly how do we use this formula. Please stay tuned. I'll be back just now. Hi guys, welcome back. So we are still looking at financial math, specifically future value annuities. I showed you the formula just before we went to the ad break of what exactly it shows us and how to then look at every label of that particular formula. Now I want us to use the formula with few questions, and I will be throwing in some other concepts that you need to be familiar with in order to solve financial maths. So let's look at our very first question that will require us to use the formula. So firstly, I want you to think about how people save for retirement, right? Let's say you want to start saving for your retirement and you start with 700 Rand as an investment into a savings account every month, and this is for 40 years, right? That would be maybe you are now 25 and in 40 years you'll then be 65. If the annual interest rate is 12.5% compounded monthly means that you are then getting this 12.5% divided into small portions that they're going to give to you on a month-to-month basis. Not that. So let me please explain this. It does not mean that every month you are getting 12.5%. No. 12.5% is for the whole year, but given to you in smaller portions that will amount to 12.5 on a month-to-month basis. So maybe let's use 12%. If you're using 12%, it means every month you are getting 1%, 1%, 1%. But you know, because it's interest on top of interest, some months it will be 1.0 comma something because it's the effective interest rate. So that's what you please need to understand. You are not getting 12.5 every month. You are getting a part of 12.5 every month to make up 12.5 at the end of the year. Now, how much money will you then now have to retire after the 40 years? So what we normally start by doing is to write down some data. This data is to label everything as is. So F will be the amount that we want for retirement. X will be your monthly payment, which is the 700. N will be 40 multiplied by 12. Why? Because every month you are making the payment, not every year. So for the first year, 12 months, second year, 12 months, like that, until you get to 480 months, which is the 40 years. And then the interest is 12% per annum, compounded monthly, which is the same as 0.125 over 12, because I want to know how much are you actually getting on a month-to-month basis. So to calculate this, we will then say F is equals to X into 1 plus I. Remember the formula, to the exponent of n minus 1. All of this divided by I. I can really advise you to start by writing the formula down. This is important. It also guides you on what you need to do after that. Now, I still know I'm looking for the F, so I'm not substituting anything there. My X, we know, is the 700 rands into 1 plus the 0.125 divided by 12 to the exponent of 480, and then minus 1, and that's a constant, divided by 0.125 over 12. Now, just to give you advice as well, please, when you write down the 0.125 over 12, do not first press that on the calculator and get the answer. Because in financial maths, we don't round off the answers until we get to the final answer. So you will end up rounding it off, which will make your answer to be off by a few decimals. 125 over, all right, so let me quickly, 0.125 divided by the 12, and then I want my exponent, which is 480, minus 1. I close the bracket, all over another fraction, 0.125 divided by 12. And this will give me, let's see how many numbers are here. There's 7 of them, so it's 9,600,000 and something. So I'm just gonna say this is 9,600,000, and I will be 51,537, 51,537, comma, the cent is 72 cents. 72 cents. And then what you can always do after calculating, you can say therefore and conclude that this will be 9,651,537 and 72 cents. Now, do you wish to retire at a certain age? If you know how much you will need, you can also find out how long it will take. Now, with this one that we just did, we knew how many years I want to invest, right? I'm 25. I know that at 65, I want to retire. So that means I have 40 years to do that. And I have 700 rand that I can spare every month. I get 9 million something. But now, I don't know really how long to invest, but I know how much I want to get, right? So this is when you set your goal to say, I want to retire when I have, say, 10 million. Now, if I invest 700 Rand, how long will it take for me to reach 10 million? This is what it means. Now, with this one, it says, let's say you wish to start saving for your retirement. You estimate that you will need 4,500,000 in order to retire, right? So that you don't really stress yourself. You invest 5,500 a month at an interest rate of 12.5, still the same, still compounded monthly. How many years will you have to wait in order to retire? So the 4,500,000 is our future value. The X will be the 5,500, N will be the number of payments that I don't know as yet. And then the interest will be 12.5%. So let's just quickly look at, it says how many years. So we will need to divide it by 12 at the end. So remember again, my formula, X into 1 plus I, all to the exponent of n minus 1 divided by I. And then I know that my future value is the 4,500,000 equals to 5,500, and this into 1 plus 0.125 divided by 12, this is a 5, all to the exponent of n, which I don't know, and all of this is divided by 0.125 over 12. By the way, the n here, I must just multiply it by 12, because if I divide this by 12, then the n must also be multiplied by 12. Now, back to our calculator. This is what I will have. I will just work out almost everything here. 4,500,000. Multiply this by the denominator. 125 over 12. It gives me that much. I divide this by 5,500. It will give me that much, and then I add a 1 to this. I will be at that price there. So 419 over 44. 419 over 44. And this will be equals to 1 plus 0.125 over 12 to the exponent n. Now, if you look at my solutions and how I'm writing these numbers, I'm trying to be strategic about it. Why? Because if you round it off, I promise you guys, it's going to make your answer to be off by a couple of thousands or hundreds or cents, right? So always make sure that you don't round off. That's one of the instructions that we give you, that you don't round off your answers until you get to the very final answer. So always write them as fractions, because to write 10 decimals is a lot of work. Now from here, I will then introduce a log. This is times 12, right? I will then introduce a log. And if I introduce a log, which will be this, let me just quickly write it down for you so that you can see what I mean. So 419 over 44, I hope. Let's just quickly verify. Yes, 44 equals to 1 plus 0.125 divided by 12 to the exponent of n. If I introduce a log, n will be equals to log. My base here will be the 1 plus 0.125, divide this by the 12, and then, because that is the base, and this will be all to the number of 419 over 44, right? So that's how you introduce the log. So, and you can see I'm still trying not to round off my answers and write them as decimals, because it's really going to confuse the final answer. All over 12. Let me close this bracket. Then here I will have 419 over 44. And this will be equals to 217, right? So But remember, this is 12n, by the way. So let me just quickly verify that. So it means my n will be equals to, this answer here, this is months. I need to divide this by 12, right? In order to convert it to years, which will then give me 18 years. So this will be 18 years. Now, whatever that I have after the comma here just has to do with how many months then I will need to do this. If they had said to us, we want this as years and months, then you would subtract 18 from that number and multiply whatever you are left with by 12 in order to get how many months are there. So let's do that, just so that you can know how to do it. But this, they just wanted us to find it in years, right? Not really months. So what I'm saying is I will then subtract the 18, which will be that much, and then you will then need to multiply this by 12, which will then give me 1 month, you see. And then after months, you know, it's weeks. After weeks, it's days. So it is always just a long calculation. But here, you will then say, therefore, it will take, so here you do need to conclude, 18 years to reach my goal. Reach my goal. Or you can say 18 years to retire, because that's what they had wanted us to do. So firstly, let's quickly just do a recap of what we've looked at here. We knew that I wanted to retire with this amount of money, 4,500,000. I have 5,500 that I am willing to pay on a month-to-month basis. And then the bank is giving me 12.5, a financial institution, because it's not always just banks, right? And then I want to know how many years this is going to be. So firstly, it becomes number of payments. If you divide it by 12, then it gives you the years, as I just said now. So that's how you look at it. You calculate. Just the new concept that you guys are doing will be the log that you need to introduce so that you are able to calculate this, because you cannot convert these to have the same base, because that's how you can solve exponents. And then you know this will take you 18 years. So 18 years is not so much of a long time, right? But it will always depend on what are your needs and what are your goals. And that's how you then use this particular formula. Hi guys, welcome back. So we are still looking at financial maths. Now we're going to look at sinking funds and to see exactly what this is all about. Remember, I made an analogy about buying a photocopy machine, having to replace it. The difference between the two prices is what we are talking about. So now we're going to put it into an actual calculation and then see exactly how do we go about to calculate a sinking fund. And how do we then fund the sinking fund? I know it sounds interesting, right? Stay tuned. So remember that we are now looking at sinking funds. And with this sinking fund, I want you to think about how companies save for their assets, right, that depreciate. Because as a company, one of the rules, I think, I don't really have a company, but I'm sure this is what they think about, that if I buy this truck or I buy this car now that needs to transport the employees and the goods of the company, in 5 years' time, this car will be a liability, meaning it would have lost value, it will need us to fix it every now and then. So it means in 5 years, we will need to replace this particular car. But concurrently to buying it, we then do what? We set up a fund to say, in 5 years when I need to replace this, I will not just replace it. I will sell this one that we bought today in 5 years' time, and then the money I get there, I will top it up with what I was putting on a month-to-month basis, and then buy the new car, maybe a bigger car that will now transport bigger goods or more goods or a lot of other people as well. So that's what I'm thinking they think about. And this is what we're really going to be doing here with this particular question. So let's look at a scenario that has to do with company A. Now, there are two ways of calculating the asset's depreciation, right? There is what we call the simple decay, or depreciation, which is also known as straight line depreciation. So this is when the rate at which your assets are depreciating is constant throughout. So this is just a straight line going down like that. It does not fluctuate based on inflation or anything like that. No, it's just going down on the same rate. Then the compound decay or depreciation, this is what we call the reducing balance. This means that yes, it is decreasing, but it might be decreasing at a lower rate somewhere because of maybe inflation reasons or the prime lending rate that is taking place, how much it is, and all of that. So this is not so much of a straight depreciation. So it is not depreciating at the same rate every year, although the interest rate is the same, but it's not the same in terms of the amount that it takes away. And then we have formulas to this. The formulas, how you can just remember them, it will be simple interest and compound interest, but with a minus, right? That's just how we can say, remember this. It's just a simple interest, but now with a minus, compound interest with a minus. That's how you look at this. But remember, we do give you these formulas in the information sheet. Now, with the concept of sinking fund, as I said, this is a type of fund that is created and set up purposely for repaying debt. This simply means that the owner of the account sets aside a certain amount of money regularly and uses it only for a specific purpose, like replacing or upgrading machinery or equipment that has depreciated over time. Now, Company A purchases a truck for $250,000 now, right? The truck is expected to depreciate at a rate that is 23% per annum. And really, this is something that happens in real life, by the way, because the rate of depreciation, especially for these big machineries, is very, very, very high because you use it for goods that are heavy, so the mechanical part of the truck will be jeopardized after 5 years and all of that. Hence, it is so high. This is on a reducing balance because it cannot be on a straight line because it's the years are not the same with the truck. Closer to the time you want to replace it, you might find that it's now too much of a liability than the first 3 years. And then the company is expected to replace the truck after 6 years. So my example here will be for 6 years. The replacement cost of the truck increases by 19% per annum, compounded annually. So this is on a year-to-year basis. Now, the first question I want us to look at is we need to calculate the value of the current truck after 6 years. What does this mean? Let me tell you what are the different ways they can ask this. So they can say scrap value. This can be called the scrap value, right? This can be called the book value, or they can just call it the value of the current truck after a certain time. So just if you see those terms, just know they all mean one thing, and that thing is the depreciation that we're talking about. So we will be reading the different questions as we are answering them. Now, what you're going to use is the compound decay in order to calculate this. And these would be the data that I have for this particular question. And for me to then do the calculation, I will say A is equals to P into 1 minus I to the exponent of n. And this will be equals to 250,000 into 1 minus, the I here will be the rate of depreciation, which is 0.23, and this is for 6 years. And therefore, you just go straight to your calculator, and this will be 250,000, 123, into 1 minus 0.23, all raised to the exponent of 6, and this will give me 52,105. So this will be 52,105, and let's quickly just look at the cents, 60 cents. This will be 60 cents because you need to round it off to 2 decimal places, right? Now, look at what is happening here, guys. You bought this thing as a company for 250,000. After 6 years, you can only sell it at 52,000. So the difference in this is more than 180,000. So you can really see that this is a big loss. But because the company knows that the truck will be costing a bit more after the 6 years because of the inflation of 19%, they then also calculate how much the truck will cost, the new truck that they need to buy after the 6 years. So, therefore, they will say A is equals to P into 1 plus I to the exponent of n. Now we are talking about inflation, right? Because it is going up, not going down. Hence, is a plus. So this will be 250,000, 250,000 years into, just remember this is 5 into 1 plus the 0.19 to the exponent of 6. Now I'm not dividing anything by 12 or anything because they said it's compounded annually, right? So the 19% is for 1 year, the 6 years, every year you get the 19%. So it's not gonna be affected by the compounding period. You then also go back to the calculator, 250,000, 123, into 1 plus the 0.19 or 19 rather to the exponent of 6, and this will be 709,940. So 709, 709 and 940,000. Now let's just quickly look at how many cents this will be, 21 cents. Right, so now it really makes sense why companies would do such a thing, that yes, I bought it now. I know it's going to make money for us as a company, but we'll need to replace this thing. When we sell this truck, we're going to get 52,000. These are decisions that are done before or are made before they purchase the truck. When we want to replace it and buy a newer truck, a newer model, it will cost us 709,940. So now this is a lot of money. They will need to set up a fund, and this fund will be now question C. Question C says to us, you use the solution in A and B to calculate the value of the sinking fund. And this sinking fund will be the difference between the B and the A. So the new price, I will say SF, is equals to the new price minus the old price, right? Old price. But in maths, financial maths, we don't really call it the old price. Let's just use the correct terms. We can say this is scrap value, right? Minus the scrap value or minus the book value. That's just what you need to do. So I'm going to go back and just look at my numbers. This is 709,940. So I have 709,940, and I think it was 21 cents, minus the book value of ours, which was 52,105. 52,105, and I think it was 60 cents. I will just quickly verify that. Yes. So we are on the right track. And then you just go straight to your calculator and you subtract 709,940, 21 minus 105,60, and then you find that. So they will need an extra 657,000 a year. This is a lot of money. 657,000 and 834 rands. 834 rands and how many cents? 61 cents. 61 cents. And that will be the sinking fund of this particular company. Meaning, as I just buy the truck today as my company, I will then open simultaneously an investment account. The investment account, I will be paying a month-to-month installment that will accumulate to 657,000, as you saw on the board now, right? Because as a company, as much as we are making a lot of money, there is really no way that in 6 years' time we will have 600 and something thousand just from our revenue in order to just throw into buying this new truck. No, we must be strategic so that we don't then put the company at risk by using all the money that we have as the company. Hence, we set up this monthly thing. But this monthly thing, we're going to calculate it just now after we come back from the quick ad break, which I want us to take now, just to look at what we've done so far. When we come back, we're going to look at how do I then set up this fund and how much must the company pay on a month-to-month basis in order to make up this much money that they need to top up the scrap value. Stay tuned, I'll be back just now. Hi guys, welcome back. So now I want to give you guys a quick background of what we've been looking at, because this last question is what sums up the concept of a sinking fund. Now remember, we started with company A, let's say company Khumalo, right? I'm using my surname. Khumalo's company bought this truck. And this truck depreciated to a value that is 52,105 rands. And the company also wants to buy a new truck the same time this is sold for that 52,000, and the new truck will be costing us as a company 709,000 and a couple of hundreds, right? Now, I know that I need to set up a sinking fund for my company for a difference that is 657,000 and other hundreds there. To do that, I will open an investment account. The investment account will be giving me an interest rate based on how much I am depositing on a month-to-month basis and based on how much I want to get at a later stage. So now we need to find how much money must my company contribute into this investment account on a month-to-month basis in order to make up an amount of 657,000 and the couple of hundreds. I just don't remember the actual figure, right? That's what we are going to do now. So let's quickly just recap in terms of the data that we have. Now, we're still looking at sinking fund. The company, as I said, purchased for 250,000. It depreciated at that and it gave me a value of 52,105 and 60 cents. And on a reducing balance, the company is expected to replace. When I wanted to replace it, it increased up until it got to 709,000, I think 940 and 21 cents. I hope my memory is not failing me. And this was compounded on a month-to-month basis. So the question says, calculate the monthly installment paid into the sinking fund, right? The sinking fund, remember we said is the difference, which I'm going to show you how much it is. It's that 657,000. And the bank says we're gonna give you 15% per annum, compounded monthly, and the payment starts 1 month after the truck is initially purchased. Now let's quickly explain this, because some people will think I must add 1 month on top of the 6 years. No, what it simply just means is I am buying the truck now. I can't immediately then start the investment as well now. No. 1 month after is simply just 1 month after I have bought my truck. That's when it starts losing value, and that's when the bank will then give me the interest, right? So they will give me the interest from that 1 month up until it gets to 72 months, because that's 6 years. That's what it's simply. So you don't add or subtract one or anything like that. Now, remember, we need the future value formula. Why future value? Because this is the amount I want to get in future. It's not the amount I have now. No, I want to get this amount in future, so that when I then sell this truck that I have for the amount I'm selling it for, I can accumulate this much and withdraw it and then top it up, buy the new truck that I want. And the number of months or number of payments will be 72. I want X because I don't know how much I must pay per month. And I will be the 15% that the bank says we are giving you. Now, to do this calculation, we then gonna say F is equals to X. Remember, we always start with the formula, guys. You don't just jump into substituting into something that I cannot even see where you get it from, right? Over I, I'm gonna substitute everything I know and then solve for what I do not know. So this will be 657,834 and 61 cents. This is equals to X, which I do not know, 1 plus 0,0125, I mean, all of this divided by 12. Let me actually write it as the original one, right, without the answer itself, so that it does not really confuse us. This is 0,15, it's 15%, divided by 12, all to the exponent of 72 months minus 1 divided by 0,15 divided by 12, right? And then I know from this, I can then go straight into the calculator. My amount is still there because that's the last thing we calculated. I'm going to multiply this by 0,15 over the 12 divided by 12, and this will give me that answer. Then I must divide this whole thing by whatever is inside that bracket that I have there, the bigger bracket, right? So this will be 1 plus 0,15 over 12 to the exponent of 72 minus 1, and then voila. It means my company must then pay an amount of 5,686. So X will be equals to 5,686, I think. 686, yes. 686, and how many cents? This will be, also, it's just gonna be 87 instead of 86 when I round it off. Because you remember, you need to round it off to 2 decimal places. So the number there is 9, so I must add 1 there, making it 67. So this will be the amount I need to pay per month. So I'm sure you are really thinking about this. It makes more sense for my company that even if I am making a lot of money, let's say for argument's sake, to pay 5,687 rands per month for 72 months than to wait for the 72 months and take out 657 from my account as the company. Really, that will not be a wise decision. Hence, the concept of a sinking fund is there. so that you make smart decisions as companies out there, because you guys are also going to start companies one day. We all have aspirations to be big in life. So when you do that, these are the things that financial maths can assist you with. Without you even going to a financial advisor or anything like that, you can just do your calculations and then go to the advisor to say, I've done my calculations. Is this okay? What do you think I am missing? And then they can give you the advice, because you do need them. But you can always just use the financial maths that we're teaching you. So this is how relevant this concept is. So remember, everything that we've looked at so far, we've looked at the concept of an annuity, which you really, really need to understand. This is about making regular payments, right? The regularity of it has to do with per month, and you are getting an interest on a regular intervals as well, and that differs based on the institution you are using. Then you also need to know how to calculate the future value annuities using that future value formula, or just the F, because some people use future value, some use F on its own. So that's all, guys, I have for you. I hope you've learned so much and you are enlightened, as well as you have been able to see how to use this financial maths of ours in your real life situation, should you wish. It does not need to be big companies. It can be a small company that just sells little things that give you maybe 1,000 rand or so. You can also use financial maths to boost your company. So it is not only about the big companies. So please just make sure you know that. Guys, I've had so much fun talking about this because it's so relevant to our everyday life. And I hope you've also had so much fun learning about this. But from me to you, I have to love and leave you. Remember, mathematics is food for the soul. If you do it well, I promise it's going to be well to you. Until next time.